Everybody, welcome back to astronomy. Like I said in my video on Thursday, today's Friday. Instead of doing a lab this week, I'm going to introduce the final paper. And because this is a shortened version of the class, I don't think I'm going to be able to do the thing that I like to do, which is to let you turn on a rough draft and then to give that back to you with feedback and then give you some more time to work on a final draft. There's just not enough time to get both of those steps of the process in. So this paper will be due the last week of classes. And what I will do instead is I'm going to, when I put the assignment up on Canvas, I'm going to put a paragraph in the assignment description with the kinds of feedback that I typically give students on their rough drafts. I've been doing this assignment for quite a while. I used to do an assignment before I invented this one where students would just do sort of a book report style paper about a NASA mission from the past, the Galileo mission to Jupiter, or the Cassini mission to Titan, or the New Horizons mission to Pluto. And they would do a little report about that mission. And it was an okay assignment. Some years I made them do in-class presentations about it. But this assignment, I think, is better because it makes you think more critically about the reasons why these missions are important or interesting or can teach us things. So I've been doing this for probably 6 years now, and students, when they do their first drafts, they tend to miss the same sorts of things. So I've got a whole document full of comments that are the comments I usually leave on people's first drafts. So what I'll do is I'll give you those comments preemptively so you'll know not to make those mistakes in the first place. So I think that'll give you about 4 weeks or so to work on the paper after you choose your topic. You might want to wait till the end of next week to choose your topic because we're going to talk about some things that we haven't talked about yet, Europa and Titan and comets and asteroids and stuff like that. What is the paper? Let me actually go to my sharing here and share the, where is it? What is the name of the document? Why isn't it showing up? Oh, do I only have it open in preview? Hold on, I might only have this document open in preview, so I can't show it to you. No, I should be able to show it to you. NASA Mission Priority Assignment, PDF. Sorry about the delay here. I'm not sure. My computer's not letting me share this one particular document that I want to share to you. Share screen. Preview. There it is. Just had to bring it to the front. So hopefully you can see this document. Now let me scroll to the beginning of it. This is the assignment. You are to imagine that you are the assistant budget director of NASA, and it is your job to choose how to spend NASA's money. And NASA only has $500 million set aside for exploring the solar system. And your role as scientific advisor is to recommend a mission that NASA spend its $500 million on, but you only have enough to choose one. There are 6 missions to choose from. Those missions are: 1, a sample return mission to Mars, where you go send a spacecraft to Mars that brings back samples of Martian rocks and soil to Earth. 2, a mission to land a rover on Jupiter's moon Europa. 3, a mission to send a drone-style flying robot and a robotic submarine to Saturn's moon Titan. Spoiler alert, there's something for submarines to do on Titan. We'll talk about Titan next week. 4, a mission to land robotic rovers on Pluto and Charon and continue on to explore the Kuiper Belt. 5, sample return missions to a comet and an asteroid to bring back samples of comet and asteroid material to the Earth. And lastly, a probe to explore the atmosphere of Venus and sample its atmosphere and analyze the chemistry of the atmosphere. So your assignment is to write an executive summary advocating for one of these 6 missions. Choose whichever one you want. There's no wrong answer. But what you should do in your paper is explain why this mission is important and what sorts of things we could learn from it. Specifically, what are the unanswered questions about Mars or Europa or Titan or Pluto or whatever mission you choose? What are the unanswered questions left behind from past missions? So your paper should do the following. It should be based on the scientific importance of the mission. It should include details about past NASA missions to that object and what those missions discovered. So this is your chance to talk about, say you chose the Saturn one, the Saturn's moon Titan was your choice. It would be important in your paper to talk about the Voyager missions to Jupiter and Saturn and what they discovered, and the Cassini mission to Saturn and what it discovered, and what questions about Saturn and Titan, those missions, left unanswered that this new mission could potentially answer. What you should not do is give me a long book report about the object. For example, if you choose the Mars mission, I don't want you to waste 250 words saying Mars is the fourth planet from the sun and its diameter is so and so 1,000 miles and its average temperature is this to this. No, we've talked about all that in class. Okay, I want to know what are the unanswered questions about Mars, what specific discoveries were made about it by past space missions, and what we still feel like we need to learn about that object. Okay. The other thing is, don't spend a lot of time talking about why you wouldn't choose the other missions. I've had students in the past spend just as much time talking about why they wouldn't go to Pluto and they wouldn't go to a comet as they do choosing the ones that you don't have to do that. You're just talking about the mission that you select as your choice. Lastly, don't spend a lot of words just restating the things that I have told you in this assignment about the missions themselves. We'll see that in the next page. Your paper should include references from at least 3 or 4 reputable sources. By that, I mean sources other than Wikipedia, although you're more than welcome to use Wikipedia for basic factual knowledge about things. If you want to find out what past NASA missions discovered about Jupiter or Saturn or Europa or Mars, the best sources, NASA websites and scientific papers and articles about those missions. Your final paper should be between 1,500 and 2,000 words. That's not a very long paper. That's what's that, 3, little more than 3 single space pages. So it's not a big, long, giant paper. The word count doesn't count references. If you spend a lot of time just restating the assignment in your paper, I delete those words before I do the word count. So 1,500 to 2,000 words of actual new content. That's stuff that you wrote. Okay, so that's the assignment. I think it's an interesting assignment. I think it gives you a chance to dive a little deeper into the knowledge about one of these objects, at least, than we have time to in such a quick course. So you can assume that the missions, oh, this says 5, there are actually 6. I actually added the Venus mission 2 semesters ago when we discovered some new stuff about Venus. So it says 5, but there's actually 6. These are not real NASA missions. If you find a real NASA mission with a name that's similar to these imaginary missions I've given you, that's a coincidence. These are missions that I have made up in my own head that might share features with proposed and current NASA missions. I don't want a book report about some proposed real-world NASA mission, but if there are real-world NASA missions that have the same goals as these imaginary missions, you can certainly cite NASA websites that are explaining what it is they hope to discover with those missions. So you can assume that all of these 6 missions have the following. There are cameras, so they take pictures of all the stuff they encounter. They can measure the temperature of their surroundings. They can measure magnetic fields. They can measure the chemical composition of any soil or any liquid or any gas that they come in contact with. So they have the ability to have spectrometers or mass spectrometers or whatever to measure the composition of the material they come in contact with. Okay, so all the probes share the same basic functionality. Here's a more detailed overview of the 6 options. One is called Mars Prospector. It is a sample return mission to Mars. The prospector will have the ability to dig up to 1 meter deep, so 3 feet deep, and extract samples from the rock. The lander will return several kilograms, the equivalent of about 2 cinder blocks worth of material of Martian soil, rocks, and ice back to Earth so that we can analyze them in the lab. As part of the secondary mission, the rover will actually remain behind to explore and photograph Mars for 2 more years. Option 2, a Europa lander called Talos, which is a mission to land a probe on Jupiter's moon Europa. It includes a rover with a heated probe that is capable of melting through 1 meter of ice. The rover will be able to travel up to 50 miles across the surface before its batteries die. There's not enough solar power out where Jupiter is to run a solar charger. As part of the secondary mission, the orbiting part of the spacecraft that dropped off the lander will continue to orbit Jupiter and photograph its moons for 2 more years. So we can learn things about some of the other moons as well. Option 3, exploring the surface of Titan. Project Orpheus is a mission to send a small trio of robots to Saturn's moon Titan. There are 3 parts of the lander: are a rover that drives around, a drone that flies around, and a robotic submarine that swims around. Each robot will have some sort of camera and instrumentations identical to all the other probes, and they will have a working lifespan of about 2 months before their batteries die. As part of the secondary mission, after the lander descends to Titan, the orbiting part of the spacecraft will continue to observe Titan for an additional year, and then shift its orbit to orbit Saturn's moon Enceladus for another year. We'll talk about Enceladus a little bit next week. Option 4 is a mission to Pluto and Charon. It sends a duo of robotic landers, one to land on Pluto, one to land on Charon, similar to NASA's Mars rovers from the past. The space probe that drops off the rovers will actually continue out of the solar system into the Kuiper belt and eventually go into orbit around an object in the Kuiper belt called a quasar. Option 5 is the Comet Asteroid Sample Return mission. It contains 2 identical landers. One will land on a comet, one will land on an asteroid. They're not rovers, they land, they pick up a bunch of rocks and ice, and they launch those samples back to Earth. Each lander will sit on its comet or asteroid for 1 full orbit of the comet or asteroid and make measurements and take photographs the entire time. And finally, this was a new one. Aphrodite is a Venus mission. The mission consists of an orbiter that will orbit Venus for 2 years and an atmospheric balloon that will descend into the atmosphere, produce high-resolution radar maps of the surface, study the climate and atmosphere and greenhouse effect of the planet. The atmospheric probe, which is sort of like a hot air balloon, will survive in the atmosphere for roughly 30 Earth days. It will ascend and descend and measure the atmospheric temperature and composition at different altitudes. So that's the missions. This next session I'm going to have to throw away. We're not doing the rough draft, and so I'll have to revise this before I post it up to Canvas with the due dates. Like I said, the due date will be the last week of classes, essentially. So that's it. It's going up on what time is it now? It's well, by the time you watch this video, the assignment will be posted to Canvas.